Hello everybody, I'm your host Hal Curtis and I'd like to welcome you to The Space Industry by SatSearch, where we share stories about the companies taking us into orbit. In this podcast, we delve into the opinions and expertise of the people behind the commercial space organisations of today who could become the household names of tomorrow. Before we get started with the episode, remember you can find out more information about the suppliers, products and innovations that are mentioned in this discussion on the global marketplace for space at satsearch.com. Hello and welcome to today's episode. Today I'm joined by Ignacio Chechile from ReOrbit Space. ReOrbit is a Finnish manufacturer of reusable space systems. And today we're going to talk a little bit about the meaning of NewSpace and how different spacecraft architectures and the concept of software-defined satellites are leading to new opportunities and creating new discussions and new avenues of progress in the industry. So Ignacio, great to have you here today. Thank you very much for being with us.
Hey, yes, thank you for inviting me. Yeah, great to be here.
Great. Now, your work at ReOrbit, I think, is a really interesting area of the industry. Now, when I say the industry, I think we usually mean NewSpace, and NewSpace is often sort of talked about as a movement to where the cost of access to space is being reduced through some form of innovation, often funded by the private sector. For you personally, and speaking on behalf of ReOrbit, I guess, what does NewSpace mean, taking into account what you've seen happening in the industry recently?
In my opinion, NewSpace is a very broad concept. Of course, I mean there is like a lot of different people doing many different things in NewSpace. What is called NewSpace. What is NewSpace to me? Remember, I'm seeing this from the satellite manufacturer perspective. So I'm kind of narrowing it down through that perspective. NewSpace is, in a way, something that I discovered around like the 2010s when I realized that it was possible to do space without the NASA logo, like stuck to the missions, right? Without the space agency's logos, like all over the place, meaning that private people could do space without the big guns paying attention or sponsoring, right? That was to me the first kind of big changer, the big, like game changer when I came into the topic. I mean, it was clear that it was possible to do space without having like hundreds of millions of dollars in budget. That was also a game changer for me. Now, clearly, the big enabler for this to happen was launch costs, coming down, and that was possible by means of the rideshares. The rideshares becoming available, to be possible to fly tourists, to be possible not to own a full rocket for you, but just ride a rocket with others. That brought the costs down like dramatically, and that opened the door for like many small actors coming and doing like cool stuff and with small spacecraft, right? That was the game changer to me. And that's what NewSpace means to me in the beginning. That's how the door opened. Now NewSpace then became it developed in time, and it became a bit of a constellation, Earth observation, change detection, many technologies that are kind of now possible, because of the rideshares or the launch costs, like decreasing. And I have to say, we need to thank the traditional space for that, because the traditional space was the one creating the rideshares for the NewSpace to be able to fly tourists. So in a way, it's a bit ironic that NewSpace exists, in my opinion, because of classic space, making it possible by means of the rideshare. It is still the case because, still companies, startups cannot pay for a full rocket. So still rideshares are like very much the enabler, right? So that's NewSpace, if I see it from my perspective, that's NewSpace to me.
Great. That there is an important thing to note that NewSpace is in debt to the traditional space domain.
We should not forget about that, right? Because somehow NewSpace can have this sometimes, this a bit of a cocky attitude, and maybe it's a little bit of it's thanks to to classic space, and that's fine. We don't have to look back a lot to that, but we need to remember, right?
When we are looking back at the traditional space domain compared to things in the new space sector, specifically in the area of spacecraft architectures, what do you see are the biggest areas of divergence between the two areas? Why do they exist?
There is a huge difference. In classic space, spacecraft architectures are extremely what is called like federated, meaning that one computer does one thing. There's a one-to-one mapping between the functional architecture and the physical architecture. And it makes sense. It also related to how the companies or the space agencies were like formulated back in the day, right? Like full teams of people doing one thing, attitude control, power systems, comms, you name it, right? NewSpace, on the other hand, it came to break a little bit that mapping between the functional architecture and the physical architecture. What I'm trying to say here is that one computer does not exactly map to one function anymore. Or that is the trend, let's say. You can have, for example, your attitude control algorithms running in one computer, alone and exclusively, or you can have it, along with many other functions, on some, computer as well, and kind of, running along with, the power system and the thermal, software control. And that to me is a big change. Now, classic space, again, there is a dose of over engineering over there. There's good reason for that. I mean, over engineering comes from this, high stakes, serious missions that if lost, would create a lot of, problems for like many people. Now, that over engineering is costly, and of course, NewSpace cannot afford it. And in a way, NewSpace also came to cut the signal from the noise, let's say, in a way that there was a lot of over engineering that, because of not being possible to be afforded, then NewSpace discarded it. And of course, it came with some risks, but those risks were taken in a, I would say, in a planned way, not just like blindly. And it gave way to linear architectures where, as I said again, computers can be doing more than one function, which also reduces mass and reduces complexity of operation and many other, like reasons. Another difference is that, for example, the way you operate a new space satellite compared to how you operate a traditional satellite, it's also very different. I mean, in classic space, every bit that you send to the satellite means something. There's a zero overhead policy. It makes sense because, the link budgets and because of this and the bandwidth. There's a lot of, reasons behind that. But new space is like, it's more like treating satellites as, computers connected over a network, like a laptop. It's like a server like a server over a network or across a network, and that brings a lot of facilities. It also brings some problems and some challenges because it becomes a sysadmin problem, right? It's like a system administration issue more than a satellite operations issue. But it really, really streamlines, the operation of a remote system like a satellite. As I said, maybe to summarize this question, on one hand, traditional space, highly federated, highly specialized, equipment. On the other hand, new space architectures where the roles of computers it can have like different functions, and it can also change with time because you can reconfigure the computers after you launch it and say, okay, now you are not doing attitude control anymore. You are taking care of the power system software or something like that. So that is that's how I see these two things, right? I mean, of course, the division sometimes is blurry, but if you ask me, what is the colors of these two sides, classic versus new space in terms of architecture, this is how I see it.
Brilliant. Yeah. So it's about an increase in versatility, and there are drivers for that. As you say, there are the technological ability to actually develop it, but also on the demand side, satellite data requirements are changing and the market will change. And if satellite systems are able to adapt to that faster, then the opportunities will increase. So great. That's really interesting. Thank you. Now, and kind of towards the end of the edge of the innovation envelope in this area is the work that you are doing at ReOrbit on software-defined satellites. What does the concept of a software-defined satellite mean in NewSpace?
I hope you have some time because I get a bit passionate on this one.
Of course, of course.
I mean, there is one ugly truth that I have seen in many different, missions and in companies, that I've been working with, and there is an ugly truth that finally someone has to say open and loud. In satellites and in space, software rules. I know a lot of great mechanical engineers. I know a lot of great, thermal engineers and a lot of, electronic engineers. They are great people. But in a space mission project, the software guys are the guys with the power. And why? Because it's related to the previous question as well. When you have an architecture that you can kind of reconfigure and you can, define the different roles as the mission evolves and all that, it is all enabled by software. I mean, there's no way you can change a bolt from one place to another place easily in space, but you can change software. Software is your asset. Software is what can, allow you to say, no, you're not doing this anymore, you're doing that. You can change the function, you can change the roles, you can change how data flows, in what direction, how it's stored. Software is the real asset. And companies ignoring this, they end up creating architectures as well. Coming back to the previous question a little bit, is that they create architectures that are ignoring this fact, that software is the real asset. And they shoot on their own, feet, because then they launch satellites that are very rigidly, like configured to do one thing. Since I joined ReOrbit a year and a half ago, we've been brainstorming a lot about the software defined concept, because there is a lot of, I mean, it's a big buzzword as well, right? People just use it like very loosely. Oh yeah, software defined this, software defined that. What it means for us, software defined, is that when you have a remote system, you need to operate a remote system. It can be a satellite, but it could also be a nuclear plant, or it could be a power plant, or similar, right? When you have a remote system that needs to be operated, you are interacting with the software. So you are that's what you talk to. I mean, that's what that talks back is the software. Then when your architecture is a little bit decoupled, then you always talk to one actor in this architecture, this remote architecture. You talk to the onboard computer in general, and then the onboard computer goes like through different pains and issues to go and talk to some other slave computers to send commands back and forth. It's a bit of a mess. So what we're working on here is that, okay, a satellite, it's a collection of computers, and we are not going to change that. You will still have like several computers. Now we are saying that these computers, they share a bit of a common, it's like a common memory space, even though the memory is not really physical, because they don't share the same memory chips, but they share a satellite. They are all flying on the same object, and as such they need to share data, and they need to be aware of data from other computers in the satellite. So we created a little bit of a virtual memory space, and we say, okay, now all the computers are aware from each other, and all the computers, if they need from data from some other computer, they just ask for it, because they know that, hey, this number that I need is owned by my fellow computer connected through my CAN bus or my space wire bus. So we configure the satellite in that way, that we don't really mind, or we don't really think about the interfaces, or we don't really pay a lot of attention to the space wire driver. I mean, of course, we have to have space wire drivers and CAN drivers and UART drivers, because you have to. But what we care is about the data on board, how the data flows. But for us, software basically handles data. If you don't really know what your data is, then there's nothing you can do on board of a satellite. And we extend that concept to the ground, because from the ground perspective, the operator also needs to get data and send data. A command is data. Telemetry from a satellite is data. And we make that data flow as seamless as possible, because at the end of the day, what an operator is doing by sending a command, they want to modify a position in memory of some computer on the satellite, whatever that is. And we have created a set of abstraction layers that we make sure that the operator doesn't really need to care too much about where exactly the data is sitting on. It's more like, I need this data, give me the data, basically. And that, at the end of the day, just to put a little bit of practical coating on this, it is software abstraction layers. So we create those abstractions that from the ground the operator doesn't need to care. And why we do this, because also we are looking kind of a little bit ahead, because eventually we want, at ReOrbit, we are trying to make satellites also fly together, network together in orbit. And we also want to extend this concept to the constellation. When you have data on several satellites, imagine that you have a formation of 10 satellites flying over your head. You cannot operate each one of those satellites individually. So you need to create a bit of a sense of a flock. And that's why we are just looking forward and saying, these abstraction layers will eventually in the future allow an operator to operate a formation of satellites passing over their heads. And that's what software defined means for us. We want to dissect the problem of operating a remote system without the space halo. Satellites have been launched for 64 years already. We don't buy that halo anymore. I mean, it's like satellites are satellites. They've been satellites for decades. Let's just move on and think about how to operate them in a proper way. Sorry for the long answer. I said I get passionate.
No, that's really, really interesting, really clear. Yeah, looking forward to those applications that you talked about, for example. And as you say, the fact that launch costs have come down, which you've mentioned, and we've seen in other areas, the miniaturization of subsystems means that you're able to launch more cheaply satellites with a greater number of sensors and greater capacity to do all sorts of different applications. But determining how you manage those applications and determining what you task the satellite to do is a matter for the software and the operator to do so. That's really interesting. And in this area, however, there are a lot of buzzwords that are thrown around, sort of including and to greater or lesser levels of applicability. But there are AI on satellites, as an example, distributed architectures, in-orbit networking, and as you've mentioned, the software-defined technologies. And you've alluded to some of these, like the use of thinking of satellites as servers in space and that sort of thing. How mature are such technologies in your view, and particularly in their ability to provide, actual services with good reliability to end users on the ground?
Well, I mean, yes, buzzwords are a big problem in this industry. We were talking about classic space and new space in the beginning, and for some reason, unfortunately, the new space industry, perhaps coming from the startup, scene, adopted this policy of buzzwords all over the place, and that's a big change from classic space, because in classic space, kind of the missions do the talking, right? And in new space, there's a lot of marketing going around, and that is a bit of a problem because some of these technologies that you mentioned, for example, AI or software defined, architectures or distributed architectures, people just talk about them in a very empty manner, and then they start to lose the meaning because people start to take them as just yet another fad or yet another like buzzword that people are just like spouting, and that's a problem. Now, if we remove that, I mean, I don't know how, but I guess that in the future, less power to marketing teams, more power to products. That's maybe one way to go. But anyway, maybe talking about those technologies and how mature they are. Well, I mean, if you take them individually, AI, distributed architectures, and software-defined architectures, they are mature on their own on the ground. Let's say so on the ground. AI, I mean, it's of course it's maturing as we speak. It's still a early stage, of the, but still it's already. I mean, you can really see the value already of AI. I mean, when it's done in the proper way, right? Not just a list of nested if statements, but more like proper AI. It's already paying off. Distributed architectures. I mean, I don't really need to give a lot of examples on the ground. Of course, there are many examples of distributed architectures or the centralized architectures. The blockchain and all these things are kind of becoming like very very topical. Are already kind of prove that there's a possibility of having distributed systems without a single central entity and still being able to add value. And networking, I mean, I'm not going to talk about how networks work on the ground, because we are now talking here thanks to networks, so I'm not going to explain that networking on the ground is mature. Now, how to bring that to orbit? I think that this is something that is you need to gain confidence in these technologies in orbit by means of taking the proper steps. Meaning that I don't think you need to go from zero to everything. I don't think that you can go from no AI in space, no distributed architectures, and no in orbit networking, all the way to having all those features, working upfront. You need to take them slow. And slow, I mean, I'm not saying in decades, but more like you need to prepare a set of pathfinder missions where you say, in this pathfinder mission, I will showcase the in-orbit networking feature. In the next pathfinder mission, that can be just a few months away, and with very small satellites and cheap satellites, you can say, I'm going to try distributed architectures. And here at ReOrbit, we've been discussing this, how, because we're pursuing all these things, we're pursuing all these technologies. How do we make the industry aware that all this is possible? Again, for an industry that is, historically a little bit conservative because of the heritage from classic space. So we say here at ReOrbit, we say that, we kind of need to walk the talk. There's no way that you can promise in space that you will say, oh, buy from me because this will work because I say it. You kind of need to show that it works, right? And that's why we are envisioning a set of pathfinder missions where we'll say, in this particular mission, we'll try, in-orbit networking. And that means launching 2 small satellites with the capabilities of talking to each other and then exchanging information in specific protocols, being able to change those protocols and show that, hey, you can have 2 satellites in orbit, like if the same way as if they would be like, like not network nodes. And the same for the rest. I mean, for AI, we're working internally here on self-diagnostics, making sure that the satellites can have running, statistical models on board, assess the status of the power system, status of the battery, predict how the battery will, deplete, according to some scheduling. We're doing all that, but we are going to showcase those in Pathfinder missions. And from those Pathfinder missions, we are going to show the market and the industry, which again is a bit conservative, to say, hey, this was not just empty talk. This was not just smoke. I mean, more smoke and mirrors, as you will find all over the place. This actually works. And we will also equip our product line with these features as we show that the advanced features work. And I guess that that's something that we cannot fully overcome. Walking the talk requires going into taking proper steps, and the capability of launching cheap satellites, small satellites for cheap launches or on cheap launches is a good path to increase TRL or the technology readiness.
Absolutely. And yeah, as you've mentioned, that flight heritage in many ways is just binary. It needs to be done.
Yeah, and also you mentioned at some point you said reliability. I think you said that how you show this in a reliable way. And well, it's of course attached to what I said, that when you need to go slow and show it. But at the same time, reliability in my opinion is an architectural problem. It's like, I mean, we assume here internally that things will act up in space because space is hard. Now your architecture needs to be ready to overcome the things that will definitely happen, because they will happen. And I've been part of too many missions already to realize that it's going to happen. So you need to make sure that your architecture is kind of ready to, do the switchovers, do the reconfigurations to make sure that you can continue providing service after the shady things will happen, because space is space and we cannot change that.
Yeah, so you're designing for the environment, accepting the limitations that it brings. So that's great. I mean, that's covered a lot of the questions and things that I have for you today. I guess just finally, I always ask a form of this question to all of our guests. Looking into the crystal ball of the future, I wondered where you thought you saw different forms of activity in the new space sector heading in the next, 5 to 7 sort of years. What are you most excited about as well at ReOrbit?
That's a good question. I mean, I cannot really do a lot of crystal balling, because also people will replay this podcast in 5 years from now, and they will laugh at me because all my forecasts were wrong. Wouldn't be the first time. So the good way of putting it is, what is it that I'm looking forward in this industry? I'm looking forward to the trend of commoditization of space equipment to continue, meaning that that sensors, actuators, computers for satellites, they should stop being special things, and kind of very specialized equipment with very long lead times, and handcrafted natures. I would love to see that in the future you can go to a place like SatSearch and say, I want to buy 10 star trackers for my missions, and I will have them here next week. I know there's a long way for that. I think we are on the right path for this. So commoditization of equipment, I hope it will continue evolving in the way that it is evolving today. I would also love the space, as I said in a few questions ago, the space halo, right? That this aura that is kind of covering space as a sci-fi thing still, and science fiction is to me something that we're not working on science fiction here. We're working on satellites that are just a bunch of computers connected, like cars are, like a Tesla is. And that's why I want space industry to continue decreasing that space halo, that somehow we move forward, kind of overcoming the fact that yes, there are rockets and satellites going to space, and that's that. I mean, that we've been doing this for decades, so let's just move on. The process of hiring people and like scaling companies a little bit easier, because you need to stop bringing people from space. You can just bring people from automotive industry, and that's that. So that's a trend that I would like to continue seeing, right? I also would like, and this is perhaps related to my work here and what we are doing at ReOrbit, that I would like software marketplaces to be fly software marketplaces. If we are flying a satellite and you need a library for encrypting your data, or you need a library for, I don't know, a specific protocol, or you want to have a driver for a specific interface that is a little bit, uncommon or something, I would love this trend of having a place that you can go and select what you need, and then you will be able to, I mean, not very magically kind of installing the software in your satellite, but at least with some steps already kind of sorted out. So that's a trend that I would like to see. And maybe last but not least, we commented a little bit on the increasing TRL before. I was talking about this in the previous chat. I think there is a bit of problem in the industry on new actors, how to increase the TRL in a more, I would say, reliable way. I mean, a clearer path to increase your TRL, because many companies have great ideas, but they face the famous heritage problem. Now you don't have heritage, right? And then you're just kicked out of the discussion because you are not in space. That to me is a bit silly, because it's leaving a lot of great companies with great propositions and offers from joining the conversation because they haven't been in space. So they need to have a bit of a better, way of, technology maturation. And this is something that I would like to see in the next, 3-4 years, that there will be a, solid way of new actors, gaining heritage and then, maturing from there. So those are the things that I perhaps biased by my, my work here, but that's my opinion.
Excellent. Thank you very much. Well, yeah, that's some really interesting areas that we should hopefully, but maybe see in the future. And I think that'll be really interesting for the audience to think about. And yeah, thank you very much for the discussion today, Ignacio. I think
Thank you for having me.
yeah, absolutely. I think our listeners will have learned a lot about why the different concepts of new space hardware and computing exist today, and the opportunities that software-defined satellite concepts can bring. So thank you for sharing.
Thank you for inviting me.
Absolutely. And to all our listeners out there, to find out more about ReOrbit's work and portfolio, you can view the company's supplier hub on SatSearch. On the platform, you can make requests for information, technical documents, and other procurement requirements like lead times or quotes, or whatever else you might need for the development of your own missions or services in the new space sector. And beyond, of course. So thank you very much for spending time with us today on the Space Industry Podcast. Thank you for listening to this episode of The Space Industry by SatSearch. I hope you enjoyed today's story about one of the companies taking us into orbit. We'll be back soon with more in-depth, behind-the-scenes insights from private space businesses. In the meantime, you can go to satsearch.com for more information on the space industry today, or find us on social media if you have any questions or comments. To stay up to date, please subscribe to our weekly newsletter, and you can also get each podcast on demand on iTunes, Spotify, the Google Play Store, or whichever podcast service you typically use.